always make sure I start the recording and always make sure I go back to the screen and I hit stop and hit the save button. It's pointless recording it if I do not save it. I'm right there with you, Alec. I'm tired too. All right, parallelograms. So I'm starting to do it with you guys too in geometry. Like before, I felt like it was really, like it would really explain stuff, and I was like, we're gonna learn how to prove things with parallelograms. And I feel it just crams in way too much in that broad statement. So a parallelogram is a quadrilateral that has parallel sides. So we kind of talked about parallel lines. We've talked about parallel lines before, kind of. So parallelogram just means that this side is parallel to this side, and this side is parallel to this side. And these two little marks right here, that just means parallel. So all of these are parallelograms. Even a rectangle is considered a parallelogram. It is a rectangle, but not, it's kind of, okay, so here's the thing. So parallelograms, so there's quadrilaterals. It's like a big group thing. So there's quadrilaterals. Anything with four sides is a quadrilateral technically. That's more of a triangle, but you get the idea. There's quadrilaterals, and then there's parallelograms. So all parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. There's rectangles. So all rectangles are parallelograms, but not all parallelograms are rectangles. And then there's squares. So all squares are rectangles, but not all rectangles are squares. It's like a very weird hierarchy. I don't know if it gets into it here, but I know a lot of geometry classes do that. So let's get into parallelograms. So right here, they're going to want us to start talking about congruent parts of parallelograms. So let's get into this. So we want this side. 1, 2, 3, 4. They want us to do the slide and the slope for all of them. So what I'm going to do, I think I saw a YouTube comment where it's like, oh, you just have to click this. I like clicking both things when we're doing the lengths. And the reason for that is it allows me to know, it labels it for me. That's the only reason why I like clicking the dots, is it labels it for me. Give me a second here, I need to move this out the way. And that way, if I like move this around and I do something stupid like this, I still know that this is referring to this side. All right, so do that. And we'll see here that AB is equal to DC. So in the parallelogram, opposite sides are equal to each other. They're going to talk about that a little bit later, but we're talking about slide AB. Oh, they just want us, they only, the measure and the slope. AB equals 6. Do it this way, that way I know what side you're talking about too. Because if you don't, I don't like how they didn't give you a spot to label it, or they should have labeled it on the sides, to be honest. BC, P, and AB equals 2. 2. And then to do the slope, that one you just have to click the line. So you go here, you click slope, click the line, click the line, click the line. I don't know why it moves it up there. It's weird, but it's still the same slope because it still falls on the same incline. Click this line. So we have 0, 0, 0. 0 for the last two. So when we go here, we're just putting 0, 0, And what was the other one? 1.5 for the other two. 1.5, go down, 1.5. All right, so when we're doing it this way, measure and record the length of each side of a parallelogram. Were we not supposed to do that in the last one? Oh my gosh, we weren't. Well, that's why I did that. Well, at least we have it done already then. So you guys don't have to do that equal thing. I am just really bad at measuring directions, apparently. Each side. See, I thought it meant measure the side and record the slope of each side. But it's literally saying, like, do the slope and do the measurements on the other one. This one was 3.61. 3.61. My lazy. Oh, I don't think this will work. I was like, I can just copy and paste it, but I can't. This one was BC. BC and AD. So when you guys rewatch this, or if you're taking notes, you don't have to put these in. Just make it easier. All right. How are the lengths of the four slides related? So you would just say the opposite sides are congruent. There's no other way to really state that. I mean, it's just the opposite sides are congruent. It's probably word for word on this. The opposite sides of the parallelogram have equal lengths. They're congruent. This just gets way too specific. Record the interior angles of it. Okay, so I don't know why I didn't ask a question about the slope. So now it wants the inside angles. I've seen a couple of you guys do the outside angles. Make sure when it's asking for the angles, you guys are doing the inside angle. A couple of activities had it. I kind of just went like, it's fine. But you guys really should be focused on doing the interior angles when you measure these. If you don't do it right the first time, just hit the undo button and try it again. So for example, if I did the outside angle by accident like this, oops, not angle given size, just angle. If I accidentally did this, I know it's the wrong one. Go back and just do it the other way. It does take a while to get used to it. I'm still not 100% sometimes, but you get used to it. So let's say I want this angle. So I'm kind of skipping this B right here. And then I want this B. So I want to go from here all the way to C because I want to go counterclockwise. So I want to go from A. And what I mean by that, I don't think I've ever drawn it. Oh, I don't want the active stylus. No. Okay. I don't think I've ever drawn it, but let's say you want this angle. Oops. Wow, this is totally off. I guess I do want that on. No, I need to recalibrate. I didn't even know I could decalibrate. Wow. Turn this off and turn it back on. Maybe that'll help. Okay. It looks like it's working now. Nope. Great. Well, so let's say I want this angle B right here. I want to go from A, B, then C. And the reason why is I always want to go counterclockwise. So I'm going from A all the way to C. So that's why I'm saying it's counterclockwise. So if I'm measuring this, I'm going to go A, B, something happened here. Angle, A, B, C. This thing hates me. There we go. So if I want C, I want to go from D all the way to B. I'm going counterclockwise. So I go D, C. Oh, did it backwards. Wait, no, that is counterclockwise. D. Oh, that's clockwise. Duh. D to B. So I want to go from D to B. So I'm going to go here, here, and then here. If this thing registers my clicks. Oh my gosh, I'm sorry, guys. I don't know why it's giving me such a hard time right now. There we go. All of that just to say that our opposite angles are going to end up being congruent. So when we measure it, I don't care if you guys call it like the CBA or if you just call it angle B. I like calling it angle B because I'm like, what other angle would I be talking about? When there's more lines, yes, you have to be specific. But here, usually I just like it when you just go like angle A. And I don't know which class knows this. I know I've said this a few times in different classes. You can just copy and paste that. And if you want to edit it, you highlight it with the equation editor and you can just edit it from there. Oops, capital B. Always put your angles in capital letters. Later on, you'll see that when we do sides, sometimes I do it in lowercase letters just to label it better. And since I should already have it copied, yep. And D. And when I'm doing my angles, A matches with C, 56.31, 56.31. I'm not going to put the degree sign. I'm not going to mark you guys down if you guys don't put the degree sign. 123, 69. All right, so we have those. And then it's going to ask us what do we know about the opposite interior angles. So the opposite interior angles are also congruent. So it's probably going to be like in a parallelogram, the opposite interior angles are congruent. Opposite interior angles are congruent. The reason why it's going to say in a parallelogram, so in a parallelogram, is we go from saying a general statement, the statement just being, we already know what we're talking about. We go to I guess a relative statement, meaning that if we say the opposite interior angles are congruent, it depends what we're talking about. But if we say in a parallelogram, the opposite interior angles are congruent, we're saying a general statement that's always true. So the whole thing is more true than if we do this. If we say this, it's a relative statement. It depends what we're talking about. But if we say the whole thing, it's more specific. So that's how come if you submit it, you'll say the opposite interior angles of a parallelogram have equal measures. They're just making it more general. It can apply for every case, not just this case. Move the vertices of the original parallelogram, change the thing. Do we notice a difference? So it's going to ask if we see a difference between the opposite sides and the opposite angles being congruent. So I'm not the biggest fan of how Admento makes us practice this because this is already programmed to always be a parallelogram. You might create a parallelogram in one case and then you move this stuff and it's no longer a parallelogram. So I'm not the biggest fan that Admento makes us try this because it's like we already proved it. Let's just move on. And you'll see that the opposites always stay congruent no matter how I move it. Hey, Giovanni, try to use your school email because otherwise I have to admit you in. All right. So you'll just see that these opposites are always congruent no matter how I change the sides, how I change the angles. And this is only for parallelograms. You can even technically make this a rectangle if you try to, let's see if I can get it there. Oh, so close. I don't think I'm going to be that accurate. But it just goes to show that a rectangle is a parallelogram when you do it. A square is also a parallelogram. So when modified parallelogram still has equal opposite sides and angles. Explain how you can prove your observations with the theorems in a proof. Draw a diagonal of the parallelograms to prove this. So when we do this, so give me a second, let me make this a little smaller. It wants us to basically do this. I need to move the C closer. It wants us to essentially do this. So if we have a parallelogram, oh my gosh. The pen's like super off now. I hate it. It's probably not going to work until like I reset the computer, which is going to be terrible. All right, let's see if it works with the mouse. And it doesn't even work with the mouse either. Give me a second, guys. This is going to bug me. If you guys have ever taken a class with me, I think right now Isaac, Alonzo, and Rebecca, you guys know that I am always at war with the smartboard, and now it looks like I'm going to be at war with Annotate. Hopefully this fixed it. I really hope it did. Otherwise, I'm going to have to restart at some point today. All right, give me a second here. Oh, that's better. Okay. You guys can't see it, but it was really off when I would write. So what it wants us to do here is, oh no. All right, well, at least my mouse is working. My pen is not, apparently. It's not working here. They want us to basically, I'm going to guess right here. Why? You were so good, Annotate. Okay, they want us to draw a line right through. I'm just going to draw a separate shape. All right, for some reason it's good on this page. It just wasn't good on that other page. But they want us to draw a line right through the middle. And because it's a parallelogram, we know, okay, how can you prove the observations in 3 and 4 using a traditional proof? You don't need to develop a proof, simply describe your steps. So what we would do is we would measure the angles, and by measuring the angles, we can use the reflexive property to say this. We would say that this is an angle. Oh, so here's what we would do. These are parallelograms. These are parallel lines. So because these are parallel lines, we're going to cut it with a transversal. Cutting it with a transversal means our alternate interior angles are congruent. So that means this angle is equal to this angle. It also means that our other alternate interior angles are congruent. So this angle is equal to this angle because of alternate interior angles. So remember when we did this, we would say that this is congruent to this and that this is congruent to that. So two of the angles are equal because of alternate interior angles. This one is equal to itself because of the reflexive property. Remember, the reflexive property is kind of that weird one that says AB is equal to AB, which kind of seems pointless, but it's used in the case of this to kind of show that this is a different triangle than this triangle, even though it looks the same. For some reason in geometry we always have to state that, because if we do not state a side in the middle, then we can't really say it. So we can't say like angle, I don't know, this angle, the green angle is equal to the other green angle. We would have angle, angle, but we never said that the sides were equal. So we have to use the reflexive property, which is dumb, I admit, to say that this angle is equal to itself, even though it's really obvious that it's equal to itself. So what we would do is, to prove it, we would say or I guess since this is going to be you, I would draw a line from vertex to opposite vertex. This is a transversal. Transversal meaning line that cuts parallel lines. So just in case you guys forgot what a transversal was, that's what it is. A transversal is a line that cuts through parallel lines, making alternate interior angles, alt-int angles congruent. The line is equal to itself, meaning the triangles made by it are congruent because of angle side angle congruency theorem. If you guys don't want to write all the words, I don't blame you. You can just write because of angle side angle. You don't have to write congruency theorem. You should mention cutting it through a line. You don't have to specify that it's a transversal, but you should say that the alternate interior angles are congruent. And state how you do this. For this one, personally, I would probably give myself like a 4, because I always have to remember what it's talking about when it's like, prove that these work. And I always forget that you have to do it by doing this. And I've taught this a bunch of times. That's why it gives you the hint right here. And that's the only reason why I remember, oh, this is alternate interior angles. So hopefully that makes sense to everyone. I know proofs are difficult. Luckily, this one, it's like, you don't really have to do a proof, just kind of explain it. If you look at the sample answer, it's like, it makes it super weird. It talks about, obviously it makes that triangles, but it states it. It goes like, oh, you can prove the two angles are congruent by corresponding sides, which is kind of weird because we don't know that the sides are equal yet. We just know it's a parallelogram. So this angle honestly doesn't even answer the question correctly. And that's why these are called sample answers, because sometimes they don't answer it correctly. All right. So now we're going to do a quadrilateral is a parallelogram, then the opposite. If a quadrilateral is a parallelogram, then the opposite sides are equal. So anytime you hear the term parallelogram, you know now that this side equals this side, and this side equals this side. And it also proves that opposite angles are congruent. So now that we've proven that, we can say it. Well, we haven't proven it yet. We're going to go into the proof right now. I honestly think these proofs go into way too much detail. So that's why you'll see me skimming through a lot of it. So right here, they're like, oh, we're given these points. We know that they're parallel because it's a definition of a parallelogram. We are going to cut a line. So let me draw that real quick. We're going to cut a line through this. And then that's where it says this alternate interior angle thing. So it's going to say that this angle is equal to this angle because they're both insides and opposites. So that's why it's an alternate interior angle. This side is equal to this side because of an alternate interior angle, BCA. So BCA. Oh, they're saying these sides. Why is it saying those sides? BCA. BCA. Okay. I was like, what? I don't know why I said ABC. BCA. BCA. Okay. You can check that on your own. BCA is equal to DAC. DAC. So hopefully you guys can see the colors well. I probably shouldn't have picked green and blue. They're too close together, I think. Those are congruent because equal parts equal sides. That's kind of weird to me that I would say that. AC is equal to AC. That's the one that I said it's a reflexive property, which is kind of weird. But the reason why we have to do that is it gives us angle side, angle. You have to treat these as two separate triangles. So at some point in time, if we're pretending that these are two separate triangles, you have to say that this is equal to this. Even though they're right next to each other, they still make you prove it. From there, we can say that this side is equal to this side because congruent parts of congruent triangles. So because the two triangles are equal, this side has to be equal to this side. Congruent parts of corresponding sides of congruent triangles are congruent. All right, so now we're going to do the exact same thing, but we want to say that the opposite angles are congruent. So first of all, we're going to say that the lines are parallel because it's given to us that they're parallel. So first, this forms a parallelogram. Then we have to say that the lines are parallel. That's going to be, let there be a parallelogram. So sides of the parallelogram are congruent. Okay, so this is building on the last proof. Sides of a parallelogram are congruent. So we're going to do, wait, not that one. Oh, this one. Sides of a parallelogram are congruent. Oh my gosh. They're getting really specific with this. Then they want this meaning that. So this one says that the sides are congruent. This one says that the measures are congruent. I think this is a repeat of steps. I don't know why they're doing it. I'm sure you guys are really bored hearing me kind of go over this. But yeah, I really hate that they have to mention this one. I've never been in a geometry class where they're like, oh, you say they're congruent? What does congruent mean? It's like, that's already known. You don't have to explain what congruent means. So now we're going to draw a line across the middle. We're going to draw that AC line. So they want us to draw a line segment. So if we're going to draw a line segment, we're going to do this. Draw a line. So we're drawing two diagonals. So because we're drawing two diagonals, that's going to let us do this. Oh my gosh, are you serious? We have to prove that the diagonals are congruent. So they're saying this. If you're doing this and this red line is congruent to that blue line. That's what they want you to say. It's a reflexive property because it would say that this triangle is equal to this triangle. And then if you do it the other way, this blue triangle is equal to the red triangle. So that means the red line is equal to the blue line. Just so you guys can visualize it better, it's saying this red triangle is equal to the blue triangle also. I know I'm covering it up, but let me see if I can draw it better. It's saying these triangles are equal, which means this line has to be equal to that line by definition. So because those triangles are equal, we can say this, which means we can say that opposite angles are congruent. So because we're saying that this triangle is equal to this triangle, we can say that this angle is equal to this angle. I don't even, let me view the diagram to see what it's talking about. Edmentum's really weird. I'm sorry, guys. Especially with proofs. I don't know what it is with proofs. Yeah, okay. So, oh, that's what it's saying. It's doing two at a time. It's doing a twofer. It's like, hey, these two are congruent because of congruent. It's basically doing the exact same proof. It's just doing it twice. So we can prove both of them at the same time. One thing, too, you'll notice I pointed out that the diagonals are equal. Now we're going to actually do that part for realsies, not me accidentally explaining it ahead of time. So let's go into Adventum. And we're going to draw these. Make sure they're line segments. They'll make them lines. That and that. This one I'll just do the easy way, just clicking on the line. Because we're trying to prove that they're equal. Did I click on the right line? All right, now I'm not sure if I clicked on the right line. To my knowledge, these two should be equal. That one's 3. Oh, interesting. I'm not sure what's going on here. Did I forget something? Oh, well, let's do that. So, draw lines AC and BD. AC and BD. Record the length. I'll record the length before I move them. There we go. I don't know. Oh, label point E. Oh, duh. I'm sorry, guys. Diagonals are not equal to each other. The diagonals bisect each other. Give me a second here. Sorry, guys. Like I said before, I think I'm just tired. Let me just do this. Go from here to here. Get that. 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 And that. That. And that. So you'll see that they cut each other. So the diagonals end up bisecting each other, meaning they cut each other in half. So A to E, C to E, E to E, and D to E. The BC was 1.5. BE, sorry. And then the AC was 2.5. CE, the same. Based on your measurements, what can you tell about the relationship? The diagonals cut each other in half. Them in half perfectly. They bisect each other. Bisect means cut in half. All right. That cut in half, the midpoint. Oh, okay. Angle E is the midpoint. That's another good way of saying it. Move the vertices around, see if this does it. Like I said, I always think this is dumb because it's programmed to be a parallelogram. If you do this with any other thing besides Edmentum, it wouldn't work. So yeah, you'll see that no matter how I move it, it's always the same. No. the relationship remains the same. Let's look at the other one. Explain how you can prove this with a triangular proof. Okay, so we're going to try to prove this down. So if we cut them in half, what I would do is I would say this angle is equal to this angle um, because of alternate interior angles, meaning that this angle is equal to that angle because of alternate interior angles. So let me see if GeoGebra starts playing nicely now. Oh my gosh, it's still off. So I'm going to draw it over here just to make it easier. So we have this. We're going to cut this in half. Cut this in half. So I'm going to say that because of alternate interior angles, this angle is equal to this angle, and this angle is equal to this angle. And then because I already know that it's a parallelogram, opposite sides are congruent. So that means this side is equal to this side, right? So because of that, then I can say that this side of the triangle has to be equal to this side of the triangle. And the reason why I say that is, look, the red one is touching the red and the green, which means this red one has to teach, this red angle has to touch the green and the yellow. I don't know why I said red and green. So this red angle touches the green angle and the yellow angle. So because of corresponding parts of corresponding sides, these two are congruent. Is this making sense, guys? I haven't heard from you guys in a while. Are you guys awake? You guys knock out? You guys can write something. Okay. One of you's alive. So that's what's happening. Is it making sense though, guys? You can type in the chat or turn on your mic and answer if you want. Cool. So I would draw the two lines, say that I always call it alt-int angles. Alternate interior angles are congruent, then opposite sides are congruent. And you can see it. You can always draw a picture if you want to make it easier to keep track of what you're saying. Opposite sides are congruent, meaning that the triangles are congruent. Like I said before, if I drew it, I'm talking about this triangle and this triangle because of the angle side theorem. Meaning that I can say that this angle, let me do a different color. This angle is equal to this angle, and this angle is equal to this angle. Because of angle side angle, thus the lines bisect each other. Because they are congruent. Halves. It's cutting it right down the middle. Bisect each other because they are congruent halves. If I say they're congruent, it's kind of saying that the lines are congruent, which, as we saw to my embarrassment, diagonals aren't congruent. They just bisect each other. Now go to the diagonals of this one. So we're going to go to this one. Okay, these are diagonals. Okay, and make the midpoints touch each other apparently. So divide the line separating the two. Okay, so I'm gonna grab this E. What? Okay, you'll see the two segments, blah, 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 have midpoints. Okay, verify that the midpoints divide them equally. Really? All right, so they just want us to measure it. Let me see what we're doing here. We're gonna measure this. Boom, 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 boom. So, yep, they are equal. So give me a second here while I prove this. So I say AE, AE, these are both 4. EF, DF. Well, which one was those? Those were 2.24, 2.24. Record your findings. There we go. Move AC so the midpoints collide. So can I move the whole line? Oh, I can move the whole line. Okay. And it'll snap in there, it looks like. So if you get close enough, it'll just snap right in. All right, so we did that. I have a feeling it's going to make me connect these two, and connect these two next. All right, so move them so they collide. I did that. Measure and record the slope of the quadrilateral. So first it wants me to draw the quadrilateral. So if I want to do that, what I'm going to do is I am going to use this polygon thing and click on all the sides. A, B, C, D, A. There we go. And now it wants me to measure the sides. So sorry, I know I'm running low on time. Do this, do this, do this. And we notice that they're all equal. So I'm going to skip that for now just to hurry it up a little bit. So we're going to say that AB, we're going to record all of our angles, write them down. I need to get in the habit of doing that, let you guys kind of finish this on your own because I tend to run out of time when I don't do that. Or actually, I'll finish this activity and we'll just finish this off on what's today? Tuesday. On Thursday. Sorry, I lose track of what days it is. So we're gonna write that down, write all of it down, put it in here, and it wants us to figure out the slope. So just remember when you want slope, you do this one. Record all your slopes. All of your opposite slopes should be congruent, 0.067, 0.67, 0.67, negative 0.4, negative 0.4. They're congruent. You can write those in there. Based on your measurements, what can you conclude? I can conclude that these two are a parallelogram. So I can conclude that the shape we made with the bisected sides is a parallelogram. Suppose that you repeated steps 5 and 6 with different segments. How would your conclusion be? So let's say I did this. I think it would still be the same. I think if I did this with any two bisected lines, so by bisected, again, I mean the midpoints are colliding. If I do this with any two bisected lines, I could draw a parallelogram with the ends of the line segments. So if I have two bisected line segments, you can't bisect a line because the lines go on forever. Two bisected line segments, I can make a parallelogram, and or I can make a quadrilateral, and that quadrilateral would be a parallelogram. How does the conclusion relate to diagonals of a parallelogram? Well, because we're doing this here, what happens is these are the diagonals. This line right here, this line segment that you originally had over here, these two are diagonals. So that's why we can say that. So the way we would say it is if you have two diagonals that bisect each other, then the parallelogram's the same. So that's a lot of words to consider. You guys might want to rewatch the video and just kind of take what I said and put into your own words. And then evaluate how you think you did. All right, so next week we'll start off on slide 12. If you guys haven't answered the attendance question yet, it's what do you miss from pre-COVID? I call it the before time. Anything pre-COVID, I'm like the before time. Um, so what do you miss doing that you're not able to do or that you can't really enjoy as much anymore? We had some good ones. One of the ones I said was, let me turn off the recording.